In this lesson, we examine the common misconception in terms of vulnerability, including the claims that systems with newer operating system will have fewer vulnerability. The second one, same thing for the newer programming language that will have less vulnerability. Well, a vulnerability exists on a well-patched machine running newest operating system? The answer is yes. The command and SQL injection attack we have successfully demonstrated and performed are on Linux machines with the most recent Fedora Fedora operating system release, and also patch with the most recent patch. Both operating system, web server, and MySQL database are patched with the most recent patch. We still see it being attacked, and the reason is this vulnerability is not coming from the operating system library or this server. It's coming from applications, and it's coming from ill design, not properly designed, not well implemented web applications. And major reason for that is the web program was not trained and educated with secure software engineering techniques and new secure design patterns. The operating system and network library, even though they have been patched, the most recent release goes through the best practice for this Linux and those network library distributions. And therefore, typically they are going through very rigorous testing and software scanning. And therefore, we see much fewer vulnerability in those operating system, low-level network library. It is not the same case in the application domain. We hire high school kids. We hire programmers that is not trained with secure coding techniques. And therefore, we often have quite a variety of this kind of source of this program coming from different sources and provide application code. And it makes the screening of this vulnerability there very difficult. Will the vulnerability exist on a more modern programming language with type-safe features such as Python, maybe in the Swift that being proposed by iOS, Apple? The answer is yes, that can still occur. Here is the example of a web app provide AWS access, key and secure key access given an account and password. It's written in Python. Through a key access.html web page in your Chrome virtual machine, we can actually enter the login and password and the input data submitted to this vul.python script in the CGI bin directory. The result will be the corresponding access key and the secure key return. This script is written in newer Python programming language, but it contains exact the same kind of command injection vulnerability we show it on using PHP script reg.php. It accepts exact the same malicious string ~ls ~, just 4 characters there, and it will display the content of the working directory, which the server side script result, which is /was/w CGI bin. What command we can use to display the password file in this directory? The answer, I will let you think about it for a second. The answer is cat command. You just say cat the password, and it will showing the actual content of the password file in the CGI bin directory. Here we show the actual code of the Python server-side script and discuss its vulnerabilities. Line 27 to 29 read in the input variable. And we can spot right away, based on the security design pattern, there is no validation code for that, right? We need to see some code that with the if statement and the head contain regular expression. Okay, we didn't find it there. 959 shows the formatting of mail command. And here, the last variable, we have 3 variables there, showing out by the ampersand sign. The last variable is login, and if we look at the corresponding formatting string in the front, it actually substitutes the -c parameter of the mail command, which is the carbon copy parameter, which specifies the list of user will send a copy of the email. Line 59 shows the os.system function, and this is the way Python script allow you to execute by providing OS command, and has the same effect. It too was too generic, and it should be, according to our security design pattern, any generic kind of function code should be substituted with more specific function code meet the purpose. In our case, we should use specific mail command. Since the mail command variable contains the variable login from the initial user input, this vulnerability is very severe and often be classified as such in scanning tool. Here we show how to patch this Python script. Between lines 34 and 35, we insert the regular expression matching functions. And if the result is not matched, we print out the error message and using sys.exit function to exit right away. The input validation code is inserted right after the input data, as you see right there. And after we read the full name, login, and password, we insert that input validation code. Line 79 use the sendMail method of the imported SMTP object from the SMTP library. It is specific function used to send email. We are not using os.system generic system code. You shouldn't use that in your future programming practice.